easy to talk about it. Most of these things are going to sound pseudo-familiar. It's just, what do they look like inside diagrams? What do they look like? What are the properties they're going to use? More often than not, excuse me, more often than not, it's going to be, when you see these terms or you hear me use these terms, you're just going to be able to recognize what I'm talking about. They're not difficult at all. They really, really, really aren't. For example, do you know how to define a circle? What a circle is defined by? What constitutes a radius? Because you're not wrong. What is, all right, real quick, what is the radius? Okay. What is the radius, though? Nope. Where does the radius, where are the endpoints of the radius? Sir? Yes, the edge on the circle. So the radius is the segment that is the distance from the edge of a circle to the center. A circle is defined by a set of points. So a circle is just a set of points that are all equidistant to a center. That equidistant portion is the radius. I mean, these are the kind of things that we're talking about. You guys know what a circle is. You know what a center is. The center is the center point of the circle, where all the radii extend from. You know that a diameter is twice the radius. The diameter does what to a circle? It cuts it in half, okay? You know that. You know that a radius goes from center to the side. You know that the radius is half of the diameter. You know that, let's see, you know what a semicircle is, right? What's a semicircle? Okay, what portion of it would make it a semi? Think of it a semi-annual sale. If a semi-annual sale, how often does that happen? It happens twice a year, so a semicircle would be half a circle. Okay, it's things like that that you have heard before. You just might have forgotten. Okay, so we're going to kind of go through these as they come up, just so you guys know there will be a few terms you might. For example, central angle. That's something we haven't really talked about in terms of a circle. Major and minor arcs, adjacent arcs. You haven't seen that. Arc length. I know you haven't seen it in concentric circles. So we have a few things as they come up. You'll see, all right. But let's look at these. What I want you to do is kind of draw a circle and then put two diameters in it. Okay? I want you to put two diameters in it. And we're going to define a few things. We're going to define these three off of this real quick. We're going to say this too. Now, when you talk about these things here, if I say that AE is a diameter, and I say that DC is a diameter, that means it cuts the circle in half. Okay, both of those, the circle could fold up on itself and go from there. That also means that if you have a circle, how many degrees does it take to get around a circle? 360 degrees, good. So if a semicircle, how many degrees would be in a semicircle? 180, good. A semicircle is half of a circle. Okay? A central angle. Central angle is an angle whose vertex, excuse me, what word I'm talking about, is at the center of a circle, and sides are radii. So a central angle is just an angle whose vertex is at the center of a circle, and the sides are made up of radii. Excuse me. For example, in this case, angle AOC would be a central angle, because the vertex is the center of the circle, and the sides are radii. Central angles are really easy to figure out because their centers are always at the vertex is always at the center. Pretty real simple. Now that central angle, that AOC, its endpoints A and C, it intercepts the arc. It intercepts that arc. That arc from here to here. Should probably talk about that real quick before I talk about major and minor arc. An arc is a portion of the circle. Of the circle's let's say portion on the circle, because it can mean a couple different things. It depends on what the word before it says. And we label it, instead of with a segment bar, we would say AC with an arc. Let me just put a little stat case in for it. The letters, just like with angles and stuff, tell you the direction. So if it says arc AC, it means it starts at A and it goes to C. If I say arc AD, I'd start at A and go to D. If I say arc ACD, that means I start at A and rotate all the way around to D. So that's where you get into these next two things called a major and a minor arc. It all depends upon degrees. Okay? A circle measures how many degrees? 360. A semicircle would measure 180. So a minor arc is an arc that measures less than 180. Now I'll put this in here. Usually 2 letters. And then a major is an arc more than 180. And it usually uses 3 letters. And I've got examples for all of this stuff. I just wanted to talk about the terms. They're super easy to work with. They're really, really easy to work with. This is where the main thing's going to come then. So if you have a circle, this thing called the central angle, and this would be its intercepted arc. It's where the angle hits. Those 2 degree measures are always the same. Okay. The measure of a central angle and the arc that it runs into are always going to be equal. We measure of the central angle, bless you, equals the measure of the arc it hits. So if I say that AOC is 110, what would arc AC be? 10. So if AOC is 110, that means this arc is 110. And then, remember how we said AE was the diameter? How many degrees are left then for COE?
7.
Yeah, which means CE has, what's arc CE then? 7. That means this would be 70, that's 70. Vertical angles, there's 110. Hey, look at that, there's 110. Oh, look, vertical angle 70. Oh, look at that. Oh, there's another 70. And so on and so on and so on. just like we did before when we had just two lines that intersected. You had all those vertical angles and supplementary angles. Hey, guess what? If you've got two of them here, it does the same thing. Right? It really does the same thing. What would the measure of arc DAE equal? DAE. Very good. Remember, if you're just adding up, going from one arc to the other, when I say 3 letters, that means it's usually more often than not, 97% of the time, it's going to be what we call a major arc. Start at one spot, work all the way around. If you know the measures of the 3 arcs in a row, you just add them together, just like you would with angles. If you had angle addition, we'd add 3 angles together. Just like segment addition, you would add 3 segments together. You can add arcs the same way. Yes, ma'am. DAE. You can do it either way. So if you knew what the inside angles were, that means that those arcs have to equal the same. Because the central angle will equal the same thing as the arc. Always. Okay, central angles and arc measures will always be equal. Central angles and arc measures will always be equal. Excuse me. And then obviously the semicircle is just, it will always measure 180 degrees. Okay. Not too much for first day back, is it? Well, you just say everything's too much. That's fine. I'm used to that. What's that? Sure. Yeah, and what I meant by this major arc thing, and I've got an example here that I'm going to hand out to you guys, so you don't have to try and draw the circle with all the different parts to it. When they're talking about these ideas of major arcs, they're telling you what direction to go. Follow the letters just like you would before when you followed your angles. You do the same thing. It just tells you which direction you're moving, and just follow it. Okay? They're really, really, really easy to work with. It's just a matter of getting accustomed to working with them. For example, and I apologize for not getting these things pulled much. We ran out of time with that. So what, are you going to come at me with your requested idea? And I'm just looking at this. If there's one question here in the middle. Sorry for this. It's much quicker. This is easier. Put away your phone. Stop playing Candy Crush. You might learn something. Let's see. I want to look at as you guys get it. There's a question bank of 10 questions. 9 through 18 on just one circle. Okay? And I want to look at just that one example and walk you through how this stuff is going to look. If I'm not mistaken, it said that PR and QS were diameters, I believe. Is that correct? Okay. So if those two guys are going to be diameters, that means that from here to here has to add up to equal how much? 180. Good. So if I have 180 and I know 2 of my angles, what's left of that one in the middle? What do I do to figure that out? All right, what do you get? Morning, Josh. We have 180 degrees for this diameter. Okay. So we know that 64 something and 42 have to add up to equal 180. So you take the 180 and we'll subtract out, what is that? 108? 74? Yeah. Okay. And same idea. Yes, sir. Exactly. And that's where I was going back to this one. We're given the fact that you have those 2 diameters. So if you go back up to that QS one, that means those 3 have to add up to 180. Well, hey, lo and behold, aren't these 2 here also vertical? So what does that have to be up there? 42. Which means then QUR has to add up to 180 with the 42, which gives you, yes, ma'am. You get the same thing. But sometimes if you see it that way, that's cool. Otherwise, if you recognize that you've got vertical angles, it works as well. Either way, you're getting the same answer. And then, so if you take 180 and you subtract out the 42, what are you left with? 138, I believe? And does that give you all of your central angles? Notice we haven't looked at a single question. That's the idea. You don't ever read the questions until you fill in information on a diagram, especially with this type of stuff. Especially when you have those problems that have 10 questions on one picture, you never do it the other way, okay? Because you'll be there forever, and you'll have to do the double workload. So much cleaner just to pick a spot and go. Now, as we go through our list of arcs, if you read them, what's PQ? 42. Okay. Now, see what I meant by TPS? See how it's using 3 letters? If I am TPS, that means I'm starting at T, going past P, all the way around to S. Well, I can do it one of 2 ways, can't I? I can add up all the other angles, or can I just take 360 and subtract 74? Either way. That's the idea. You fill in the blank on the pictures before you go and do anything else. The lettering tells you the direction to go. So if you take 360 and subtract out the 74, what was it, Josh? 286? Anybody else agree with me here? Or Josh? We'll take a minute and figure out those last ones, and we'll check them here in a second. All right? Simple adding and subtraction, guys. Just like segment addition, these are pretty quick. RQS. Took 360 and subtract 42, I'm assuming? For RQS? You do the same thing. It works the same. Sometimes it's quicker to just do just one subtraction, but however it works, it's fine. So if you did that, what'd you get, Josh? 288 or something like that? No. 360. Oh, I'm sorry. I'm doing math wrong in my head. I don't know right. So it'd be 318, yeah. And then PQS, the 180 plus the 42, so I get 222. PS, that's just the shortest distance between the two, so that's the 138. Okay. ST, there's your 74. RT, that's your what, 116. You okay with that one? 116. QR, that gave you the 138. TQR would be 180 subtract out, excuse me, the 360 subtract out the, or probably easier, 180 plus 64, so that'd be 1, 2, wait, I'm brain farting here. It's 180 and 64. Yeah, hello. I haven't mathed in a while. And then TQR, and then PTR. Oh no, what's PTR? You mean 182 as in also, is what you meant to say. Just trying to help you out. Arcs. Arcs are pretty easy. They're pretty easy to work with, okay? ST, 74. And then RT, what was it? 116. So what happens then is that you've got your arcs. We have major, minor, we did that one. Arc measure, we did this, measure of that. Talk about the semicircle. We did talk about adding arcs together. Yep, we've done that. Done the examples of that. I don't know why I have that down there. I want to do. Yeah. So the last little bit here I want to look at are when you talk about what are called congruent arcs. What's that? Pretty much. Yeah, that's a good way to think about it. Congruent arcs are arcs. Oops. with same measure, in same circle or a congruent circle. Now, the little semantics, you guys know what I mean by semantics? When you start wording some of these things, a lot of times they try not to trick you in some of the vocab that they throw at you. Basically, the easiest thing to think of is congruent arcs are going to be, like Josh said, they're arcs that have like vertical angles. Okay, those two arcs are always going to be the same. Vertical angles, because vertical angles are always congruent, therefore the arcs will always be congruent. When you have arcs that are in two different circles, do you guys agree that circles can be different sizes? Do you guys also agree that circles will always have the same number of degrees? Does that mean that all circles are congruent? No. And the reason of that being is because when we start talking about congruent circles, in order to have a congruent circle, I can say that this central angle, real easy, that's 90 degrees. Well, I can say that that central angle is 90 degrees as well. Yeah, the circles themselves aren't necessarily congruent because the radius they're not congruent. Now, the arc measure, 90 degrees is going to equal 90 degrees. But when we get into what's called arc length, that's how far you have to walk on a circle. This distance is obviously shorter than that distance because the radius of the circle is different. So that's what I mean by take it tongue-in-cheek. It's more or less when you're looking at congruent arcs, more often than not talking about arcs in the same circle. It's not a lot of times you're comparing them back and forth. From there. One of the things you can do, and there's an example, if you flip this over real quick and you look at number 36, the game show wheel. Because nothing says math like game shows and gambling, right? If you look at that, it says that all those portions of the circle are cut into equal parts. All those central angles are the same. That means all the arcs have to be the same. Well, in order to figure out what the arcs have to measure, all you have to be able to do then is just count the number of sections. Bless you. Well, can you count that high? I'm asking a lot. I mean, I don't think you're wearing flip-flops yet. It's not that warm, so you can't use your toes. Please keep your shoes on. So if we count, again, it's a lot of information today. I'm trying to go slow. So if there's 15 of them, how many degrees are in a circle? So if I take 360, what do I have to divide that by to figure out each one of them? See how easy this is? It's that quick and painless for most of this stuff, guys. We're not trying to get too crazy into this to start out with. The matter of working with arcs, working in and out of arcs is kind of what we're looking at for today. I don't want to get too nutty on this one. Above that, look at the problem at the very top of that page where it says 2 diameters of circle N. Everybody see that? It says 2 diameters of circle N are blah, blah, and blah, blah.